Okay, so now we're ready for number 11. 11 says which ones are polynomials and which are not. So when we look at the list, and we remember that we are not polynomials if we have a variable in the denominator, A would not be a polynomial because there's a variable in the denominator. Then we remember we have another rule that says you can't have a variable under a radical. So D, as in dog, is not a polynomial because there's an X under the radical. All of the rest of them, B, C, and E, are indeed polynomial functions. If any of them had had a negative exponent or a fractional exponent, they would not be polynomials either, but that was not the case. All right, number 12 says we have the point 1, 4 and 3, 8, and we're going to write the equation of the line. It says a linear function, that's a line. So when there's a line, we need to find the slope. So we'll find our slope first, y minus y, x minus x. That gives us a slope of 2. Then we pick a point, remembering that we're writing the equation of a line. So we are focused on y equals mx plus b. We'll put in, I'll pick a point, I'll pick this one. So I'll put 4 in for y, 1 in for x. And I come up with v equals 2. So my line is y equals 2x, because my slope is 2, so 2x plus 2. And that is the equation of my line. Now B is different because B is not looking for a line. B is looking for a parabola. Parabolas look like this. So B is looking for something that looks like this. The vertex of this one would be 2, -3. 2, -3. The vertex of the one we're looking for is 3, 1. So the equation, we want it to look just like this, but we want it to have this vertex. So that equation, I don't know what this number is, so I'll call it A. I don't know what that is. But I know my parentheses has to be x minus 3. And I know on the end I have to have a plus 1. Because that gives me a vertex of 3, 1. Now I need to find that missing number. So I'll do it like I did my earlier problem. They give me this random point. Have a good day. They give me this random point. So I'm going to plug in 2 and -4 and get my arithmetic. So A is 1/49. So the equation of the parabola would be right here, only this is 1/49. I just figured that out by plugging this point, this x and y, into my equation. I figured out A is 1/49. And then the last two, here we go. To find the axis of, or vertex and axis of symmetry, we already know our direction of opening is up, because that number right there is positive. To find the axis of symmetry, we can use the formula x equals -b over 2a. That's the easiest way. This will give me my axis of symmetry. So for this problem, -b over 2a would be -3. So your axis of symmetry is x equals -3. Now what's your vertex? Well, kids, remember, your vertex always has the same x as your axis of symmetry. So your vertex is going to have an x-coordinate of -3. Now, what about a y-coordinate? Well, to get our y, we'll take -3 and plug it in. So that would be 9 minus 18 minus 4. So I'm putting in -3 and squaring it, putting in -3, okay, and the arithmetic, that gives me -13. So my vertex is -3, -13. My axis of symmetry is x equals -3, and my direction of opening is up. Now, I've got y equals 3x squared minus 12x. Same exact process. I can see my direction of opening is up because of that +3. My axis of symmetry, I'm going to use exactly the same formula. So -b over 2a. This time my axis of symmetry is x equals 2. And then for my vertex, I remember that the x-coordinate of my axis is exactly the same as the x-coordinate of my vertex. So I'll plug 2, this is different, I'll plug 2 back into my equation. Remember, when you plug it in, you're squaring the 2 only. So 2 squared is 4, times 3 is 12, minus 24, that's -12. So your vertex, your axis of symmetry, your direction of opening. And that's it for practice test 2.